So welcome to this presentation. It is called PowerShell CLI Deserialization attacks, and that is what we're going to talk about today. And we're going to start this off with a live demo. So what you see on the screen here is my Hyper-V host. It has two virtual machines, one called Server 1 and one called Server 2. We are only going to care about Server 2 right now because that one in our demo here is compromised. So one of the fundamental things in Hyper-V is that you should be able to run virtual machines, and the hypervisor host should be protected from the compromised machines, right? So for example, if you spin up a VM in Azure, you should not be able to take over all customers in Azure just because you control one machine in Azure. So in here, we have a compromised machine, and then we have a administrator. Now I'm a different person running here on the hypervisor host. And I can run, for example, get VM, and I can see my VMs. And then I can run, for example, the command who am I, using invoke command. So this is using PowerShell direct, right? So I'm running this from the hypervisor host, and the command is going to evaluate inside the virtual machine. So when I run that, I get the result server 01 administrator, because that's the credential I provided, and this executed within the virtual machine. Now in the virtual machine, I start a script called exploit ps1. So this is running completely inside the virtual machine. And if we run now exactly the same command again, so just the who am I, it doesn't matter what command we run, but just any command with PowerShell direct, we are going to see that it did not really return the same thing again, but it returned an exception. And we see that inside the virtual machine, we have a C2 connection established back down to the underlying hypervisor layer. So here we can, for example, run calc, and we see that a calculator pops on the hypervisor. So that is not a great situation. We are going to now talk about how this could happen and what you can do to make sure that that does not happen on your environment. So we're going to start with, we're in Sweden, right? We're going to talk about IKEA, and we're going to talk specifically about the bookcase Billy. So in programming terms, bookcase is a class, and the object of that class is Billy. That is like taking the class and then setting the name and setting the price, and then we create an object based on that class. Then you can have like functions, which are then going to be invoked on the object, and that's going to use the properties of that object. Here we have a serialized Billy. He is much easier to transport than the object that is stored in memory, right? So in programming terms, that is something like you call some kind of serialized function that is going to spit out like bytes or XML or JSON or some kind of data format that is easy to send over the network, and also easy to, in this case, transport by car. But it can be like some kind of format that we can save on disk or in a database or something like that. Then we have the deserialization of Billy, which is then at the receiving side, which then runs a deserialize function. And that one takes those bytes and then it reconstructs the live object that was serialized to begin with. So here we have Billy again. If we now think in terms of a bad actor, what could potentially go wrong here? Well, the transport here is not really protected, right? So if the driver is malicious, he could potentially swap out the package and give this instead. And you end up in a situation where you're deserializing something and you don't have any trust in this deserialization, right? You're just taking arbitrary data and instructions and deserializing it, and it's going to end up with what it's going to end up with. So this is the fundamental principle of insecure deserialization. Of course, this is not going to work because she doesn't have a cow at home, so she can't really do this, right? And it's the same thing in programming. You cannot introduce new code as part of the deserialization. You can only use the code that already exists within that application. If you have, for example, a Java application, you're going to be restricted with what classes you have on the class path. And in other languages, you have their own limitations. But basically, you can only use the classes and functions that are already there. And you need to be smart about how to use those and chain those together in order to achieve some kind of impact. And those classes that are interesting is something that we call gadgets. And like I said, the impact is going to vary depending on what gadgets are available. So there are many cases where we have an insecure deserialization bug and it's a vulnerability, but there is no exploit for it because no one has figured out how to chain something together and make it actually, pop calc or whatever the impact you want. So this is nothing new, like just deserialization of untrusted data. It has been around for quite some time. There was one guy there that was like from a different planet and did this way before everyone else. But most people found out about this around like 2015 something, when there was I think it was a Black Hat talk where they published like how to abuse Java applications and how to abuse deserialization in Java applications. Then after that, there was also a variant for .NET. And after that, there's also been for Python and PHP, and pretty much every language have some kind of problems when it comes to deserialization. To summarize what we said so far, you use this serialization and deserialization all the time in applications. It's nothing wrong with that. The problem occurs when you deserialize something that is untrusted. And the impact of that is going to depend on what is available in the application. So what is then CLI XML serialization? Or CLI XML at all, I guess. So CLI stands for Common Language Infrastructure. And if you take in PowerShell, you do like $s equals hello world, then that is a string. And if you serialize that string, that is going to become like a S tags around the hello world. And this is the CLI XML serialized format of a string. And it has the same thing for, a Boolean, an integer, a byte array, and quite a few different of the primitive types. It also has support for complex types. In that case, it's going to have this format. And if we take, for example, a system drawing point, we see that this one is a system drawing point which inherits from value type, which inherits from object. And it has in this lower part the properties. This is a bit simplified. This also has like some extended properties and things like that. But the key thing is these properties. And for example, the system drawing point has a property here called isEmpty, and that one is set to false. So if that was true in the live object and you serialize, then you're going to have a true here instead, right? And you can have like objects in objects and so on. And you can like serialize pretty complex stuff. And that is what happens when you do like export to CLI XML and import from CLI XML. Those are the CMDLets we're talking about. So when it comes to the importing, we have saved something to a file. We want to now restore it back into our PowerShell run space. And we can do import CLI XML, or we can do a convert from since fairly recently. You don't actually need those Git public variants. This has been around as an unofficial thing, but now it's actually supported in PowerShell 7. And both of those are based on the PS serializer, and internally they're going to call deserialize. That's a function of that class. And you can actually call that directly. It's going to be exactly the same thing. It's just a CMDlet that wraps that underlying functionality. In CLI XML, there is a concept of property bags. And to explain that, we can take, for example, a Boolean, which is going to be false. And if we deserialize that, we're going to get false back. I mean, that makes sense, right? We had false, we serialized it, we deserialize, we're going to get the same object back. What happens if we serialize a system drawing point? We're going to get this output that we already talked about. Then we run deserialize, and we're not going to get a system drawing point back. We're going to get a deserialized.system drawing point. And that is a different class. That is what we call a property bag. And you can think of that class as, for example, like a dictionary. It basically has the properties of the original object, but you cannot, for example, access the original functions that are part of that class. So, for example, the offset method in the system drawing point, that's not going to be available through the property bag. So that means that we have some kind of special case. It doesn't really deserialize it into the original class again. If we follow all of this, we can see like how this works and step by step and so on. And I just want to do a quick shout out here to the PowerShell being open source, right? So if you're curious about how something works in PowerShell, it's actually pretty easy to just clone the GitHub repo, then use the already made scripts. And you can, in VS Code, just run a debugger. And then you can add a breakpoint to whatever you're calling. And you can actually step through and see exactly what happens internally in PowerShell. And I think that's great for everyone that is doing some kind of more advanced PowerShell. But in this case, when I'm trying to break PowerShell, it's also very useful because we can actually follow and see exactly what happens. And that is what we're going to dive deep into now. Like, is it only these primitive types that becomes the original thing, and then we have property bags, or is there more to this story? Is there more that's going to be deserialized in different ways? But before we do that, we're going to jump back to like my normal job, which is actually as an incident responder. And I don't know if any one of you had a lot to do when this happened, but we certainly had. What, like, 60 parallel cases helping different customers with hacked Exchange servers. And as part of my job as a forensic there, I looked into the exploit that was being used. One of the first ones was proxy not shell. And when we look at the exploit, we see that this is actually CLI XML. And inside the CLI XML, it has some kind of XAML payload. And if we dive into what actually happens when this is being imported inside Exchange, we see that it actually takes some user-defined types as well. It's not only those primitive types that is being deserialized. And if we look at Exchange-specific code, we see that it actually uses internally a binary formatter, which is known to be vulnerable since the previous research into deserialization in .NET. Meaning that if you're on an Exchange server when this was still vulnerable, you were able to execute code when someone imported CLI XML. And that was how the part of that exploit. It was a multi-step exploit. But one of the parts to get code execution in the Exchange backend was to actually abuse CLI XML from within the Exchange PowerShell. But even if this is a super cool exploit, it will only work in Exchange, right? Because it's in that namespace in Exchange code. This won't work if you just spin up a PowerShell on your local machine, because that's not Exchange. So you need to start an actual Exchange PowerShell. However, we could take a bunch of learnings from this, right? That these like user-defined types could potentially be quite interesting. And I ask myself the question, like, what user-defined types are enabled by default then? In, just normal Windows PowerShell or PowerShell 7 when you run it on a normal system. And it turns out that quite a lot of types are brought by default in a Windows system. This is going to change a lot depending on what you have on your system. So if you install like RSAT, then you're going to get a bunch of new modules on your system. If you install, here I have like a SQL server that adds its own things as well. And you're going to get more of these custom types with their different PS1 XMLs that defines how to handle the importing and then the formatters that controls how they are going to be printed out to the console. And on top of that, we also have the default type converter. So there is quite a lot of built-in types that are always going to be deserialized into the live object. And then basically what I did was start to look into these different types and see, is there something bad that we can do with just these default types that are available on pretty much all Windows systems? And if we just start with one, we have a breakpoint. So the breakpoint type we can serialize. And inside that we have a script block you might have noticed that it's not possible to deserialize a script block. It's just going to be a string. And there is good reasons for that. There's like multiple threads in the official PowerShell GitHub repo saying that we really don't want to deserialize script block because that can lead to code execution. However, inside a breakpoint, we see that the action property is a script block. And when you do a deserialize of this data, you see that you actually get a script block back. So it's actually possible to get a script block when it's inside a breakpoint. And the reason for that is how the rehydrate command breakpoint function in PowerShell is implemented. And it's just like literally calling rehydrate script block. So it will actually rehydrate the script block into the original thing. Meaning that we have some kind of chances of code execution here, right? But how would we execute code with a script block? It's not like it's just going to execute by itself, right? But there is this thing called delay bind parameters. So if you, for example, do a example, like do you deserialize into deserialized, and then you do a for each object deserialized.action, then this is going to execute the script block in action. And these are, of course, all over the place. So in case someone is using action legitimately, not knowing that I can overwrite action with something bad instead, then this could potentially lead to a code execution. Of course, I mean, this isn't really a great way of executing code, right? It's not that many PowerShell scripts and that is going to use action in a delay bind script block and blah, blah, blah. So, I mean, this is pretty lame, but still, I think it kind of shows that the deserialization in CLI XML is not secure. I mean, if you're using the property action in a certain way that is not documented, you're going to get code execution if you have done import CLI XML before. So I think still this kind of gives us something that we should still look in more into this. There might be some more interesting things to find here. So let's summarize what is actually rehydrating. We said that known primitive types that are like boolean and string and those kind of things. Then we have the types in the default deserializing type converter. And we have user-defined types, but we also have sim instances. All those four are actually going to be the real object after deserialization. So let's continue with the sim instances. And we can take, for example, the win32 ping status. If we create an object like this and we say the address is TrueSec, then you see that when this is printed, it's actually going to show the IP address of TrueSec. I haven't done this. This is just happening under the hood, right? So question is like, who is doing that DNS lookup? And the answer is that it's happening in the types definitions of the ping status object. So you see that as part of printing this, or creating the members, it's going to take the IP host, it's going to be get host entry and this address. And then it's going to look up that that's a DNS request, right? It takes a domain name and it gets the IP, which it then adds to the PowerShell object, which is going to be the final object in memory. And that's the IPv4 address, and you see the call there. And then as part of the formatter, it's always going to print this object back to the console. So if I create a CLI XML object that is a win32 ping status, and I set the address to my own domain or whatever, say in this case, hello world, hello world, hello world, then I send this to you and you run import CLI XML on my bad XML object, then you're going to make a DNS request to my DNS server. Or not server, but yeah, you're going to look up the name I provided. So this is another example. It doesn't really have a really good security impact, right? But it still kind of shows that if we can make someone, or if someone is gladly accepting XML from me, then I can give them some kind of badly formatted XML, and that is going to trigger an action that they can't choose. We're going to force them into performing some kind of action on their system. And if we summarize why this is possible, again, we see that the victim must have a insecure deserialization vulnerability, and the fact that sim instances will rehydrate. Then we have a useful script property in the types, and that one is also printed back to the console in the format file of that type. Let's move on to the next one. We have a MSFT SMB share, which is another sim instance. In that one, we have a get ACL to some kind of value. And again, in this scenario, we can control the different properties, right? So what if we set that path to some kind of evil server path that's gonna, steal the NTLM v2 hash when they authenticate? Then if you just run import CLI XML, it doesn't work in this case. So why doesn't it work? Because the SMB share is available on the system, but it's not loaded in the console. That is two different things. You might not think about it because when you do like a get SMB share, the module is implicitly loaded. But in this case, it won't be implicitly loaded. So it either needs to be implicitly loaded because it has been used before, or it needs to be explicitly imported with the import module or, part of some profile script or whatever. The other problem is that this property is not printed by default. So this is a good example of when it looks like it's vulnerable, but it's not really vulnerable because it seems very far-fetched. What you need to do for this to actually execute is that you need to first take some kind of module or import it in some way, then import the bad CLI XML, and then you need to do some kind of action on it that accesses all the properties. So like export to CSV is going to access all properties, including the bad property that we can control. It can also be, select star or, I don't know, convert to JSON, whatever. Something that's going to touch all the properties. So that one kind of sucks. But if you do all of that, you're still going to get this hash. So still, it kind of shows you again that it seems that it's potentially dangerous to import CLI XML. What about this type then? We have a registry type. If you look at that one, it has a formatter that takes the PS path and it does a get item property of that PS path. And the fun thing here is that this one will be printed by default and this one is always loaded in your PowerShell prompt. Meaning that if I create an object that is just a registry key and I put the PS path to my evil server and then you import my bad CLI XML, this is just going to work off the bat and I'm going to steal the NTLM v2 hash. And the NTLM v2 hash, to clarify, is part of that like NTLM auth and it contains the clear text password of the user. You just need to crack it because it's currently hashed, but you still have the password. And if you don't have SMB signing and things like that, then you can relay it and use it for other things. But either way, it is a sensitive secret that it's bad if someone steals your NTLM v2 hash. So, in other words, we can steal the net NTLM v2 hash of anyone who deserializes a payload. This works in a fully patched Windows. There is no mitigation for this whatsoever. We're going to talk about a bit more about the disclosure process and so on. But this works. We're going to see this live in a demo in a fully patched system later. And the other part of this whole thing is that it's not only the default modules that we're working with, right? If we're honest with ourselves. We have quite a lot of PowerShell modules installed on our systems. And we have, for example, everyone in PowerShell Gallery. And in there you have PS Framework is an example. And that one has its own serialization type converter. It's a quite popular one. Fredrik, the developer, is here. He's a really great guy. And problem here is that it's also dependent, like a lot of different modules, including multiple official Microsoft modules are dependent on PS Framework. And a lot of others and, a lot of others. Like it's like all over the place. It's on quite a lot of systems, this PowerShell module. That PowerShell module, PS Framework, is using exactly the same thing as Exchange did. So it's using binary formatter to deserialize data. Meaning that we can execute arbitrary code. So basically, if someone has PS Framework loaded in the PowerShell code, and then they import my CLI XML object, I can execute whatever command I want to on that system. And to be fair, I don't know if one of you have your own PowerShell modules, but have you thought when you developed your custom types and formats and so on that you don't accidentally introduce a deserialization gadget? Because there's literally no documentation around this. Like, it's not that easy to know what you can do and cannot do inside your format and types. And this is kind of where we at. So we can, if the one that is deserializing our bad object has a fully patched system and just vanilla PowerShell, nothing loaded, nothing weird, we can do an arbitrary DNS lookup, we can steal their NTL and v2 hash, and if they use the property action in a weird way, then we can also execute code. If there's an unpatched system, then there's multiple code executions and stuff like that. But these are very old, so I guess you have other problems if this is a problem for you. Then we also have the non-default modules, of course, and in those we have arbitrary code execution, which we saw an example of. But then, of course, we have quite a lot of modules when I started looking into this that have some kind of problem. It varies between stealing hashes to executing code to, deleting arbitrary files, and like there's quite a lot of different ways to abuse different PowerShell modules if we're also counting the non-default ones. So now let's talk about PowerShell remoting. And before we jump into this, do you agree with me that it's a bad idea to import arbitrary CLI XML? Or like, if I send you my XML object, would you gladly import it on your production systems? Okay, good. You know what PowerShell remoting is, right? It is a protocol to run remote commands, and you can do an interactive session and copy files, and it is really awesome. It's what we recommend the people to use. Stop using RDP and use this instead, right? Because you don't have problems with, like in RDP, you expose your credentials and things like that. So it's a really nice thing that we want people to use. And it is a web protocol that is built on SOAP, and then it's built on WinRM, and it's like a plugin to WinRM, which is the PowerShell remoting part of things. And now we're going to do a loud reading of the documentation. No, we're not. I'm going to save you from that. Instead, we're just going to look at this captured request in Burp, because that seems like it's more fun. And this is just captured PowerShell remoting traffic. And you see that this is just a normal HTTP request. It's a SOAP, it has this envelope thingy, it's some kind of, in this case, I'm doing a basic authentication, it's usually not. And if we look into the data that is sent within this SOAP, we see that it's a base64 of a CLI XML object. And if we see the command, we see the command is who am I, and then it's some kind of receive response to fetch the output of who am I, and we see that the output of who am I is wrapped in these S tags. So the output is also a CLI XML. And this is kind of what's awesome about PowerShell remoting, right? That is why you have this feeling that objects just magically work back and forth between systems. So if you have an object and then you do some kind of PowerShell remoting, then you get it back and you have all your properties and everything kind of just works. Problem with this was that didn't we just agree that it's a really bad idea to deserialize untrusted CLI XML? Because we cannot trust the remote server, right? The remote server could be a dirty client. It could be a web server that is compromised. And, we have our tiering models where we have a tier 0, and we should be able to use PowerShell remoting to a lower tier. Like, by definition, we should not need to trust the remote server. So what happens if I then discard the original command, and then instead of sending the legitimate output, I send bad output back to the client? The client could be, a MSP or something that is running a command in my system, and then that single machine is connected to multiple different customers or whatever. So the scenario of compromising a server and then compromising everyone that connects to that server is quite a really bad scenario in my mind. It's kind of almost worse than, a typical client attacking a server. A server attacking a client can be just as bad. The challenges of implementing this, though, is like you have an encrypted channel that's with HTTPS, you have Kerberos and mutual authentication, and you can't just hijack traffic to a man in the middle or whatever. But what you can do is that you remember that I said that PowerShell Remoting is a plugin to WinRM. So you can actually change that plugin to your own plugin. And since PowerShell is open source, we can just build our own plugin pretty easily. So what I did was just to clone the PowerShell repo. Then I went to the function serialize the bytes, which is where the magic happens. And then I just kind of changed out this original code to, for example, this string. So instead of sending the legitimate output, we're just going to send this made-up output and see if it actually works. And I I built it, of course, and then I hooked it with my own PowerShell plugin. And invoke command against this compromised machine resulted in this message instead of the output of who am I. And you see that the S tags that I sent is removed, meaning that this has actually been deserialized by the client. So now let's take a look at what this would look like in a bit of a larger context. So here we have the threat actor, and on this system here we have the unsuspecting admin. So here we have a SMB listener that is going to accept any type of SMB connection, and it's going to capture the net LTLMv2 hash. And here we have a connection to server 01. You see that here I have the get child item vsman localhost plugin Microsoft PowerShell. That one points to my own custom PowerShell DLL. Then under POC here, which is what I'm going to read, we see that this one is a registry object, which you see here, registry key. And you see that the PS path points to the IP of this Kali machine. It can point anywhere, right? But it needs to point to some system that the threat actor controls. So this one is ready here. And now from the unsuspecting admin's computer here, if you do, just a invoke command to the DC, you see that it returns the legitimate output of who am I. So what if we run this then against the SRv01? And this is kind of a legitimate scenario, right? Imagine that server 01 is kind of a web server or something. The threat actor has compromised that server. They have replaced the plugin, and they are just waiting for someone to come there with their PowerShell remoting. So here we have the admin that is now finally running some kind of command. And we see when they run it, we steal the hash. So this hash, as I said, is contains the password. So if I run these two commands here, see if we can make this a bit bigger. For some reason it auto defaulted to American keyboard, which isn't really my favorite keyboard, being a Swede. So we point this, let's see if we have, what is it called? It's called John netntlmv2 is the name of the file. And then we point it to some kind of password list. And we run it. Okay, it doesn't have that one, come on. So what we do here is that we crack the password, right? But the problem here is that this one might not have the password. So we need to actually guess the password of that user. But this can be done offline, right? So if this one would have the password of this, which is password like that. Okay, permission denied. Let's say sudo. So if this one has this password, and then we remove .yon no, let's see. Thing is that it's like caching. Here we go. So if we just have a word list that contains the user password, we can take the hash, which was this one, and that's the one that we just captured, right? Which is here. We can run, for example, John, which is a password cracking function offline on a GPU, and we can guess billions and billions of passwords until we eventually cracked that. And then we have the clear text password of, in this case, the domain admin. So this is a kind of an interesting scenario, I think, in terms of escalating privileges in an Active Directory environment. And as said, this works on the latest and greatest Windows right now. We're going to get into what you need to do to make sure that it doesn't work on your environment. But what happened that you saw just now was basically this, right? So it is a client, which is the unsuspecting admin, that runs a PowerShell remoting command to a compromised server. The compromised server just returns a bad PowerShell CLI XML exploit, and that one is executed on the client, right? So this is what we're seeing in another view. So we have a compromised web server, a legitimate admin PowerShell remotes to that server, and when they do that, the exploit is executed on their client, and their client is connecting out to the C2. So now we're stealing the net and the LNV2 hash. If we're doing some other type of exploits, like, they have a PowerShell module with a code execution, then, of course, we can execute code, and that's going to execute on the client. So that is PowerShell remoting. Let's now move to PowerShell Direct. And PowerShell Direct is pretty much the same thing as PowerShell remoting. The major difference is that it's not built on the TCP IP stack and HTTP, but it's built on the VM bus. So that means that you don't need network to interact from the hypervisor host into the underlying system. It uses the VM bus to do that. And the VM bus is super, super complex and not something we're going to talk about today. But instead, we're going to just go back to this kind of picture and say that, we connect over the VM bus, we execute, and we see that it's exactly the same thing, right? From our perspective, we don't really need to care how it's transported there because we're not attacking HTTP or the VM bus. Problem is that it doesn't work exactly the same way when it's loading the plugin. So when I ran just process monitor to see what happens, we see that PowerShell starts on the system with the -so flag. I had never heard of it. I don't know if any one of you ever heard of that, but that means like socket server, something like that. And it starts that to be able to accept commands. But the thing here is that it seems really, really hard to, reverse the VM bus or write a VM bus something. So instead I just looked at what commands happens before PowerShell, and we see that there is a bunch of these name not found, meaning that PowerShell is Windows is actually looking for PowerShell. It doesn't know where that is. It's using just like a relative path, which means that it's going to start in the current path and then use the search path to look it up, and it's a typical search order hijack. So we can just build our own PowerShell and then put it in C Windows, and it's going to come before the legitimate PowerShell, meaning that we can pretty easily hijack this without involving or doing something complex with the hypervisor layer. So basically we have, and that is what you saw in the initial demo, right? We are hijacking PowerShell by having a PowerShell XE, which is our own malicious PowerShell inside the virtual machine. We put that on the C Windows, so the virtual machine just picks that one up instead. And then we have our patch serialized to byte function, which is going to send the exploit instead of the legitimate command. And in this case, it's not like a client server scenario. It is the hypervisor host that is talking to the virtual machine. So the hypervisor host is going to get the bad XML, and it's going to deserialize the bad XML, and it's going to execute on the hypervisor host. So this is a virtual machine. And then, yeah, by the way, the C2 that you saw, that is basically just a reverse shell over the VM bus. So it sounds super complex, but it's kind of easy. It's just like a copy file, and then it's just using that channel to talk back and forth. But basically, we have a scenario where we can break out of a hypervisor host. This does not work by default, or it works by default, but it does not. It requires user interaction, is what I wanted to say. So you still need someone on the hypervisor host to run a PowerShell direct command towards the VM. So you can't just spin up a VM in Azure and break out to the Microsoft's hypervisor hosts, because they are not going to run PowerShell direct to your guest. But if they did, then it might be a bad situation. Yeah, that is pretty much what I found. And then, of course, I reported this to Microsoft back in March the 18th. And the story in short is that there was a bunch of back and forth, which ended in Microsoft saying that they fixed the issue. I do not agree that they or at least they did not fix it in the way that I intended. I would love to talk about someone here about how this can be fixed in other ways. I think it's a really complex thing to fix, because CLI XML is really crucial and it's used all over the place. But then I figured that a good, at least like part B to limit the impact of this, is to at least fix the PS framework code execution. So I talked to Frederick, who was really, really great about it and understood it directly. And you might have seen his announcement about a critical vulnerability that he fixed. And then, yeah, I got credit in online services from Microsoft, and I don't know if that means that Azure was actually vulnerable or not, but I didn't get any explanation for online services. But at least I think it's really nice to get public credit. And yeah, so that's pretty much it. If we look at what you should do then, so alternative one would be that PowerShell remoting and all of this stops using CLI XML. But I don't see that happening in the near future. So what we need to do instead is that we need to start with, reduce the number of PowerShell modules, or at least know what types they are creating on your system. Because keep in mind that if you have a module that is not vulnerable by itself, if you use PowerShell remoting, that will use import CLI XML. The module don't have to use import CLI XML. The module only have to define types that can be abused. So then, of course, you can harden the system that you are using PowerShell remoting from. So disable netNTLM v2 is a really good thing, right? Disable NTLM off altogether would probably be a good idea. And then no one can steal your hash. So it's a quite easy fix for that one, right? And then if you just patch to the latest version of PowerShell remoting, also PS framework, then yeah, you're covered, right? But basically, what you need to keep in mind is that the system that you are using PowerShell remoting from needs to be hardened. You cannot just use that from anywhere. And then we also have the thing for developers, which is that we need to keep in mind when we develop PowerShell modules not to create types that can be abused. And we should probably, we also need to make sure that we don't import CLI XML from the beginning, because it's probably not a good idea. But if you're defining types, make sure that you're doing it in a good way. You're not doing anything that can be abused in this way. And I guess never use the property name action, because that's another, like with the script blocks, can I just execute code in really weird situations. And then, of course, avoid, the known bad type converters like, binary formatter, and there's quite a few of those that are not recommended to be used anymore. I would love to discuss more about this if anyone is interested. I think there's this kind of round table thingies this afternoon. So if anyone is interested in talking about this, or I don't know, looking at your module and seeing if it does something weird with the types, we can look at it together. I'm here and available for talking about this, and I think it's fun, and I hope you found it fun as well. Thank you very much for listening.